Hello everyone, and welcome to my review of Quadratics for my Foundations classes. Now what's going to happen here is we're going to just see a variety of problems that you would be expected to know from this unit. Going into the first one, simplifying. Don't forget your distributive property, so the 2x will multiply the x plus 7, but the negative 3 will also multiply the x plus 7. So 2x times x is 2x squared, 2x times 7 is 14x, negative 3 times x is negative 3x, and negative 3 times 7 is negative 21. Combine your like terms in the middle, so I'm going to have 2x squared. 14x minus 3x is positive 11x minus 21. Now, as a reminder for the entire video, if you need any more help on this, don't forget to search my YouTube channel for additional information on any of these topics. Now that we've seen a problem dealing with simplifying, here's problems dealing with factoring. So on the first one, there is a greatest common factor of 5x. So I'm going to undistribute the 5x from the binomial. So 15x squared divided by 5x is 3x. That way it multiplies to what it should be. 20x divided by 5x is 4. And that's my answer on number 2. Looking at number 3, it also has a greatest common factor, but only of 1x. So 5x squared divided by x is 5x to the first power. Negative 2x divided by x is negative 2. And this would be factored completely. Now, starting on number 4, there is no greatest common factor, so we are going to take the 6 that's out to the right and look for things that might multiply to 6 but add to 5. And when I write everything out that multiplies to positive 6, the only pair that will add to 5 is 2 and 3. So my factors are x plus 2 times x plus 3. Now looking at number 5, same deal, no greatest common factor. So I'm going to look at factors that multiply to negative 8. So I've got negative 1 times 8, negative 2 times 4. I've also got 1 times negative 8 and 2 times negative 4. Now the pair that will add to negative 7 is 1 times negative 8. So I'm going to have x plus 1 and x minus 8 as my factors. Now looking at this last factoring example, you do not have a greatest common factor still, but because your a value is something other than 1, like it was in the previous problems, it was 1x squared, I do have to do a process called factor by grouping. To do that, we're going to do a times c, which in this case will be 4 times 3, which will equal 12. And we'll write out everything that multiplies to 12. So for instance, 1 times 12, 2 times 6, 3 times 4, also negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. Now I'm going to figure which pair adds to the negative 8. If nothing does, your answer would be prime. However, here, negative 2 and negative 6 add to negative 8. So I'm going to rewrite my expression as 4x squared minus 2x minus 6x plus 3. So just splitting up that minus 8x into 2 parts. Now I've got my 2 groups. Let's take a look at our first group. I've got 4x squared minus 2x. That has a greatest common factor of 2x. 4x squared divided by 2x is 2x. Negative 2x divided by 2x is negative 1. So something divided by itself is negative 1. Now looking at the second group, I've got negative 6x plus 3. The greatest common factor is 3. However, because the first sign is negative, I'm going to factor out a negative 3. That way our signs will match what was factored on the first one. So negative 6x divided by negative 3 is positive 2x, as it should be. And 3 divided by negative 3 is negative 1, as it should be. So 2x minus 1 represents one of my 2 factors. The other factor is the 2x minus 3 from the coefficients. All right, we're going to shift gears yet again. You're going to see that on these problems we are to solve and provide exact answers. So on a problem like number 7, typically I always start with graphing, but here, since it's pretty much set up for square rooting, I'm actually going to go that route and do the positive or negative root of 9. And the square root of 9 is 3, so x equals positive or negative 3, just like that. Don't be surprised if they might write it out separately on their multiple choices, like something like this, but this answer means this. That's finished on number 7. All right, on number 8, you could use your graphing calculator. If that's what your comfort level is, then that's what you should use. So most of you are probably going to say, yeah, that's what I want to do. So I'm going to use the graphing calculator since it's already even equal to 0. So y equals x squared plus 5x. Again, you can only do this if it's already equal to 0 and tap on your two x-intercepts. So look at your x values. X equals 0 or x equals negative 5 are your two answers. Don't be surprised if you see them present this instead as a solution set on tests where they put brackets negative 5, comma 0, or 0 then negative 5 could also be used to present this kind of answer. So some people get really frustrated with how they're presenting the answers. Don't get surprised here. All right, so looking at number 9, excuse me, yet again, we're going to go ahead and graph this, I suggest. So I'm grabbing my Desmos calculator and typing in x squared minus 6x plus 9. Again, this is only because it's already equal to 0. This one is a bit unusual because there's only one unique solution. It's because the vertex is lying on the x-axis. So my answer is x equals 3, and that's end of story. All right, going on to number 10. Similar to number 7, I'm going to come down here a little bit. I can actually just square root this just like I did on number 7. In fact, this one would not work out in the calculator because you wouldn't see the answer. It's imaginary roots. So I'm going to go ahead and plus or minus the square root of negative 20. Now, as a reminder, you cannot square root negative numbers with real values. So that's when we're going to use I. So I'm going to have plus or minus I times the root of 20. This problem is not done, however. You actually need to simplify the root of 20 using the largest perfect square that will divide in to 20. So if I write out my perfect squares that I can square root, the largest of which that will divide into 20 is the 4, because 4 times 5 gives me 20. So I'm going to write this as x equals plus or minus I times the square root of 4 times 5. Now my very last step is to square root what I can, which is the 4. So x equals plus or minus 2i root 5. Again, 2 because I square rooted the 4. Now there's my two answers. 2i root 5, negative 2i root 5. So I'm now moving on to the 11th example here, and I'm going to go ahead and say, all right, this thing's already equal to 0, so I'm going to go ahead and graph it, which I've already taken the liberty of doing. The problem here is that these decimals are really setting off alarms in my head saying these values must be irrational. So I'm going to go back and use quadratic formula. All right, so if you need detailed explanation of quadratic formula, you can go back to that video if you need to. There's lots of them on my YouTube channel. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And my value of a is 3, my value of b is 5, my value of c is 1, so I'm going to substitute all that in. Now, important is to use parentheses as you're doing this. Doesn't impact you as much here since everything's positive, but it's just a good habit to be in because you really don't want it to bite you whenever it does make a difference. Again, I'm substituting a, b, and c into the formula. Now I'm going to simplify everything a bit. You are allowed to use a calculator if you're having trouble doing some of this, but I'm just going to do it by hand. Negative 5, well, this is negative 5, plus or minus the square root. 5 squared is 25, minus 4 times 3 times 1. Negative 4 times 3 is negative 12. Negative 12 times 1 is negative 12. 2 times 3 is 6. All right, I can do 25 minus 12 and get negative 5 plus or minus the square root of 13 is my discriminant. over 6. Now, here I'm actually going to be done on this step, and the reason is because I cannot divide any of my perfect squares into 13 like I did on the previous problem. None of those divide into 13, just one, which doesn't change it, so that's actually finished. All right, let's take a look at number 12, where we're going to actually have to do one step here before I get going, and I'm going to have to get this equal to 0. So I'm going to add 13 to both sides, and I'm going to have x squared minus 4x plus 13 equals 0. Now I'm going to try typing that into the calculator and seeing what it does for me. So here's my calculator. I'm going to go ahead and type in x squared minus 4x plus 13, since that's what made it equal 0. Whoa, don't even see. I'm going to zoom out a little bit. Okay, so since this is not intersecting the x-axis, I know I'm going to end up with imaginary roots, and I might as well use quadratic formula like I did on the previous one. So I'm going to go ahead and set that up. X equals negative b, which is negative 4, plus or minus the square root of b squared minus 4 times, my a value is 1 here, since nothing was written, times c is 13. All over 2 times 1 is my a value. All right, so x equals negative 4 is going to be positive 4, plus or minus the square root of. Negative 4 squared is going to be positive 16, since negative 4 times negative 4 gives you 16. Negative 4 times 1 is negative 4. Negative 4 times 13 is negative 52. And 2 times 1 is 2. All right, now I'm going to simplify that discriminant a little bit more. So 16 minus 52 is going to be negative 36. So x equals 4 plus or minus the root of negative 36 over 2. All right, more simplifying needs to be done here. First of all, since it's the root of a negative, I do need to represent that with the value I. So 4 plus or minus I times the root of 36 over 2. And then I'm going to square root that 36, so x equals 4 plus or minus the square root of 36 is rational, so it's going to be 6i over 2. And there is one last step here. I can actually simplify this fraction because I've got a common factor of 2 here. So I'm going to do this over here to the top right, and x equals 4 divided by 2 is 2, plus or minus 6i divided by 2 is 3i. There's my two answers, 2 plus 3i, 2 minus 3i. Okay, so on example 13, we are going to go ahead and find the vertex. Now to do that, I would advise you to use a graphing calculator. I've already put it in, so I'm going to just zoom this out a little bit and tap on the vertex, which is negative 2, negative 13. I'm going to go ahead and put that to the side. I've got what I needed. Negative 2, negative 13 is my vertex. That's one of my two answers this problem was looking for. The other thing it was wanting is to put this function in vertex form. So first of all, vertex form is y equals a times x minus h squared plus k. Now a is simply what it was before. My a value up here was 1, so my a value here is 1 still. My h and my k actually come from the vertex, so negative 2 is h, and k is negative 13. Now all I got to do is just substitute this stuff in, and I'm going to be good to go. Y equals 1 for a times x minus negative 2 squared plus negative 13 for k. All right, the last thing I would do here is just kind of clean up how this looks a little bit. So y equals, I wouldn't write the 1 out in front. That looks a little tacky to a math person. So if it's just 1 as your coefficient, don't worry about it. X minus negative 2 will be x plus 2. You do need to clean that up. And plus negative 13, I'd write as minus 13. All right, there's a good answer in vertex form. Something other than 1, you would have just left it there. You don't want to go simplifying it. You'll see why on the next example. So when we're writing an equation in standard form, that's when we're going to simplify the expression. So if you would have started simplifying on the previous one, you would have gotten back to where you started, which would not have been a good thing. So here what I'm going to do is I'm going to actually go ahead and simplify x minus 2 squared plus 5. So to simplify x minus 2 squared, I'm going to multiply x minus 2 to itself, because that's what squaring means to do. So let's go ahead and multiply x minus 2 times x minus 2. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x, negative 2x. Negative 2 times negative 2, positive 4. All right, now I still have this plus 5 at the end. Now I've just got like terms to combine. Nothing combines with the x squared. It stands alone. Negative 2x minus 2x is going to be minus 4x. And 4 plus 5 is going to be positive 9. All right, that's it. This brings us to our last problem. A ball is tossed into the air. The function y equals negative 16x squared plus 96x plus 6 describes the height of the ball in feet y at a given time in seconds x. At what time after release does the ball reach its maximum height for number 15? Number 16, what is the maximum height achieved by the ball? And number 17, when does the ball hit the ground round to the nearest tenth of a second? Well, even if you don't like word problems, this problem should get you to at least type the function into your calculator. That's a bare minimum expectation of mine, at least, is that you see this function, let's type it in the calculator. So I'm grabbing my Desmos calculator, and I'm going to type in the function y equals negative 16 x squared. If ever they use a t or something like that, just use x instead, plus 96x plus 6. Okay, now it doesn't really look like a whole lot's going on here, but you can actually zoom this out a little bit. I actually pressed the y-axis closer together, and you do see the shape of a parabola going on right here. So I'm going to make a quick sketch of that to help me in answering my questions. So here the ball goes up and it comes back down. This coordinate is of particular interest to me, so I'm going to tap on it. 3, 150. All right, so that actually is my maximum. Since 15 and 16 both say maximum, that's going to answer 15 and 16 for me. At what time after release does the ball reach its maximum height? Time would be the x value, so 3 seconds is my answer for number 15. All of a sudden, this word problem really becomes pretty easy. What is the maximum height achieved by the ball? Well, y was my height, as it said in the problem, so 150 feet is your maximum height. Well, that was number 15 and number 16 right there, really easy. Now, as far as number 17, when does the ball hit the ground? This would be referencing the 2 zeros. However, there is a little bit of a trick. So I'm going to zoom back in to my 2 zeros right here and here. Okay, one of them is at 6.1 seconds. I'm rounding a little bit there, so 6.1 seconds. The other one is at negative 0.1 seconds. Now, the one that's of interest to me is this one that's positive, because the negative one, the ball's still in my hand and has not been thrown yet. So I'm going to actually be using just the positive answer of when it hit the ground. So this value of 6.1 seconds when it hit the ground, that's going to answer number 17 of, hey, when does this ball hit the ground? So 6.1 seconds. There's my review. Please take a look online at all the resources I've got for you in the Google Classroom. Good luck on your test, y'all. Thank you.